All right, welcome back, everybody. We're almost there. Just a real quick thing for you guys. You guys had wanted it, you got it. It's here. There is a review up. You go to announcements, midterm review. You can do you can take a look at the practice test, try to do it on your own. Wait. Why are you sounding surprised? I do my job. There's a practice exam, so you can go through, print it out if you'd like, or just write on paper, practice it. Here on this says the midterm review is those questions, the solution written out. And then if you want the video version, you can see me solving the midterm review that way. So midterm will be next Wednesday.
Is it the same amount of questions or what?
It's approximately the same amount of questions. What are we doing here?
It's only 2 questions?
I don't know. Something like that, 10 to 12, something like that. Believe it or not, yeah, only 10. I could test you on most everything I need for these first few chapters. Everything builds on itself. So there's a lot of chapter 2 questions on this stuff.
Wow.
Like interval notation. You got some freebies here. Oh, we're doing the difference quotient today. That's the good stuff right there. That's calculus stuff right there. All right, so today we are doing 2.7, 2.8. This is on graphing. 2.7 is on graphing. And here we are doing, it's called, well, scaling is the general word for it. But you might think of it as stretching and shrinking. We'll also do something called translations. Translations are just moving the base graph around. And then 2.8 is on functions and like function arithmetic, competition. We'll get there. Composition, not competition. We'll get there in a second. So recall we did our base graph for f of x equals x squared. We made our little table. And we'll plot this out. Try to get these evenly spaced, looking right. Got my y-axis, my x-axis. Let's see, 1, 2, 3, 4, 5. All right, so when we were plotting on the x and y coordinates, they give us where we're at. So -2 is left 2, up 4. -1, 1 is left 1, up 1. 0, 0 is at the origin. And f of x equals x squared is symmetrical about the y-axis. We're going to learn why later in this hour. So it basically mirrors over this y-axis. So we have a point over here and we have a point over here. So that was the base graph. And make sure it looks curved at the bottom. Don't make me give you minus points for drawing a diamond or something like that. But what happens when we do some alterations? What if I make it, let's call it g. G of x is 2x squared. Well, when we put it into our thing, our table, we'll do the same -2, -1, 0, 1, and 2. But now what we have is 2 times x squared. So this is 2 times -2 squared. That gets us 8. And then we do the same thing here, 2 times -1 squared gets us 2. 2 times 0 squared is still 0. You'll see that this 2 actually is doubling everything on the base graph. You should get a 2 and an 8. So now, rather than going left or right 1 and up 1, this graph stretches. It stretches vertically and it goes up to 2. Left or right 1, up 2. And -2 and +2 both go to 8. We go left or right 2 and we go up to 8. So it's like these have all been vertically stretched upwards. And you'll see this happens anytime this number in front, let's call it A. If A is greater than 1, it does this stretching. We're going to play with this on Desmos in a little bit. What if we have something like, I don't know, 1/4 x squared? Why don't you guys take a second and figure out what happens with the values on these? When you plug in those values, see what you get, and we'll do them as a group in a minute or so. You know I'm calling on you, Jimmy, so you best be doing. Because you're off out of line of sight doesn't mean I've forgotten about you. I think I'll copy and paste this Desmos thing into the announcement so you guys can play with it there too. I think you're gonna like it. What does the 1/4 do to our base graph? Our Y column. Yeah, what?
Divided by 4 basically.
Yeah, it's gonna divide everything by 4. So we'll have 1/4 multiplied by 1/4. We'll get a 1 there. We get a 1/4 there. And we saw f of x or x squared is nice and symmetric, so it does stuff like that. So like the 2 is down to a 1 rather than a 4. And the plus or minus 1 is really down to 1/4. That's really like low. So when that A value up front is between 0 and 1, it kind of flattens the graph out. Shrinks it. It's gone downward now. Give you guys a second, then we'll switch over to Desmos. I got a fun little toy in here. This graph wouldn't look any different than if I had 1/2 x squared, x like this, and squared it. These two are identical. And yet, oddly enough, when they have it on the inside, the math books like to say that it's widening it, not shrinking it. But it does the same thing visually. One of the best functions isn't even in this class. I'm going to show it to you in a second. The trigonometry functions show you this shrinking and stuff even better. So we have this y equals x squared is our graph. And I've got some stuff in front of it inside. We're going to look at the h and the k in a second, but I wanted to show you the a and the b, which is what we're working on now. As a gets larger, that blue graph, that it looks like it's getting narrower or all the points are going up. And when it goes downward, it looks like it's getting wider. When it goes negative, it flips below the axis, which is good stuff. So we can hit the bottom side of the graph when we go negative. And I'm going to put this back up to 1 to show you what happens when we do the b equals 1. B here is on the inside getting squared also. But it does the same thing. On most of the things we see in algebra, it does the same thing. Here's a graph you're going to do in pre-calculus B, Math 154. This is the graph of cosine x. This one really shows this scaling idea. When we do A, watch what happens to the, let me turn on that. As we do A, everything gets taller. Points move up, and it's not going left and right. It's not moving left and right. And when we do B, it does. If I move B up into 2, just zoom in on that area right there. The black line is the original line, and it only has one valley between 0 and 6.3-ish. When you do B equals 2, it now has 2 valleys, 2 hills. So it's gone through its cycle twice. And so it looks like it's compressed horizontally. When you have it inside like that, it compresses horizontally. We can take a look at other functions too. Let's take a look at absolute value of x. On this one, remember, it just finds the distance to the point. It makes everything positive. So if we do -2, -1, 0, 1 and 2, we get out +2, 1, 0, 1 and 2. So my base graph goes along the diagonals right there. It makes a nice clean V. What happens if I do this, if I put a negative outside the absolute value? What does that do to our graph?
Sorry, so negative.
Makes the right side negative, right? The absolute value is already addressed. And so it just takes what we had and makes it negative. So this will be -2, -1, 0, -1, and -2. Just making the right side negative here. And all these y values are below the x-axis. So maybe I need some hash marks there. So when a is less than 0, it flips the graph over the x-axis. This is called a reflection. Reflects over the x-axis. It's the best one to show you what this on. Let's take a look at one where the negative's on the inside. We're gonna put the negative on the inside. The negative on the inside of the absolute value doesn't do it a lot of justice. So let's take a look at y equals x cubed. And then we're gonna do y equals -x on the inside cubed. So again, we do our -2, -1, 0, 1, and 2 for our base graphs. We put them in our cubing function. -2 cubed is 8. -1 cubed is 1. 0 cubed is 0. 1 cubed is 1, and 2 cubed is 8. This graph's tall vertically. And it gets even worse when you put like a multiplier in front of it. All right, so when we plot those, we saw this the other day. We get this crazy looking function, crazy graph that looks like a parabola going up on the right and a parabola going down on the left. What happens when I put negative on the inside? Which will actually look like negative
It
on the
flips to
outside.
the y-axis.
Say that
It reflects.
again?
Sorry,
Say it again?
it reflects through the through the y-axis.
It does reflect across the y-axis. I was gonna say it makes the numbers negative,
Okay.
but
Is the
you're
same?
not wrong. It will reflect across the you're ahead of the curve here, this way. So like negative, what we're doing is we're doing negative, -2, and we're cubing that. So +2 cubed is 8. So that puts us up here. And we do the same thing with -1. -1, and we got another negative first, and we cube that. It's now +1. So we have -1, 1. 0 is good and reliable, it doesn't move. Gotta love the 0. We put in 1, and there's a negative sign there, we cube that, we get -1. And we put in 2, there's a negative with it, we cube that, we get -8. Which is down here. So this one actually does a twofer on the reflection. When the negative's on the inside and it looks similar, it reflects across the y-axis. And our y-axis is here. And so when I say reflects, like however far it was this way, it now goes that far that way. It was 2 this way, so instead it goes 2 that way. When it goes 1 this way, instead it goes 1 that way. Y equals -x cubed also reflects across the x-axis. We could say it's reflecting across the x-axis. When x equaled 1, instead of going up 1, I could go down 1. And when at x equals 2, when it went up 8, we could instead go down 8. X cubed is one of those that does both.
I just have a question, like
Yes,
the-
Jimmy, you're right. Go ahead, Joe. Sorry.
if the negative sign is outside of the parentheses, it reflects across the x.
Yes.
Oh, okay.
So y equals -f of x makes it reflect across the x-axis.
Okay.
Y equals f -x like this does a reflection across the y-axis. Now this graph, the results look the same, so it ends up looking like both. But the general rule of that's how the general rule of thumb works for this.
Professor Jones,
Yes,
I'm assuming you meant to make the y-axis negative on the first one. At -8, -1, 0, 1, 8.
oh yeah.
Okay.
My
I was
bad.
very confused.
Thank you. Good catch. Excellent. So another way of looking at this reflection, this symmetry. Let me let you guys find people still writing. Slowly roll, Jones. We got time. Do it right. Who's gonna get an A next week? Who's gonna make Pepe proud?
Do you know how much questions are in the test here, or you don't? How much they add?
What if I tell you each question's worth 100 points, what are you gonna do? So will it change how you take the test?
Yeah.
How many questions will
Will
the
it
test?
make you try harder?
If each question is worth 100 points?
Yeah,
No, not really. It just evens out, right?
it evens out. It really does. The test is worth the same percentage of your grade.
Yeah.
So it doesn't matter if I make them worth 10 each, 1 each, or 100 each in terms of your grade. But the more points I make each question worth, the more points I can penalize stupid stuff less. Like, I know you guys know 1 + 1 doesn't equal 3. But if you did that on a question where each test or on the test where each question is worth 1 point, I gotta mark you wrong. If it's worth 10 points each, I can just make you lose 1 point for having bad arithmetic. So like the more points it's worth, each question is worth, the more fair partial credit is on this.
I guess what I was trying to say is like, will it be divided evenly, like between sections, like?
They kind of build on each other, like most of the stuff we're doing in chapter 2 is from chapter 1, there will be some stuff from chapter 1.
Oh, okay.
Chapter R is kind of compiled into all of this. Because we've used all of it so far. You can do it,
Yeah.
I got faith. All right, so another way of looking at this reflecting thing. So. Well, not so much reflecting, but symmetry. Y = x squared, we saw that was symmetrical. Is symmetrical over the y-axis. But why? This is what happens with symmetry. For symmetry across the y-axis. You would think I'd be able to spell y-axis, but clearly. I am not an English major. If xy is on the graph. So is -x, y. This actually happens when y = f of -x is the same thing as f of x. This occurs. And it's for something called odd functions. We call them odd functions. The polynomials y = x, y = x cubed, y = x to the 5th. These are all odd functions because they follow this symmetry. It's kind of convenient. I mean, it's probably this is why they're called odd, because what are those numbers? They're odd numbers, right? So all of when the exponent's odd, they're all going to follow this symmetry, and we can have any combination of them. We can have x to the 5th plus x cubed minus x to the 7th minus x, as long as they're all odd, that symmetry is going to happen. And then for symmetry across the x-axis. X equals y squared is an example of this. It looks like a parabola going sideways. If xy is on the graph. So is x negative y. I'm so sorry, that is not an odd function, that's called an even function. What the hell am I doing? This is even. I am so talking about the wrong thing. All right, let's make these even numbers up front. X squared, x to the fourth, x to the sixth.
Yeah, I was gonna say, huh?
Right, like I had x squared up here and it's doing it. Over here just making shit up. The even these are called even. My bad. Odd is the one that doesn't behave the way I like. You're not gonna like odd. Because it's hard to show the symmetry. I'm gonna try. It's a pain in the butt to show visually. That is for symmetry across the y-axis. These are called even functions. And it occurs with the even polynomials. When you study trigonometry, pre-calculus B, this will include cosine of x. This is in Math 154. So there are other even functions. Then we have the symmetry across the x-axis. Whenever x is y and is on the graph, so is negative y, x negative y. This is not called odd. So odd functions have this weird form of symmetry. It's called symmetry about the origin. Odd functions. Symmetry about the origin. So let's take a look at y equals, let's go with 1/8 x cubed. So x cubed would give us 8, -8, -1, 0, 1, and 8. So if we do 1/8 x cubed, we multiply that by 1/8, we get -1, -1/8, 0, 1/8, and 1. I'm hoping this is easier to draw. The symmetry. We have -2, -1 over here. We have -1 and -8 there. -1, -1, 8. 0, 1, 1, 8, 2, 1. So it looks kind of like the x cube graph has become really flat. And you finish getting that graph because you gotta watch the magic that's symmetry about the origin. So symmetry about the origin works like this. If I start at the origin and I draw a line anywhere on the graph over here, a straight line, and that's a distance d away, I can go the exact opposite direction, a distance d away, and hit the graph on the other side. It's kind of weird. So it's kind of, it's not like reflecting, there's no, like, I can't put a mirror there. I can't make something, you know how like when you see half of your face in the mirror, it look, you've got like a full person, if you got the mirror set right. There is no set the mirror right here. At least I haven't like figured out how to set the mirror right. So it's a distance from the origin symmetry. In equal but opposite directions. I can't believe I screwed up even functions. Professor Beret is gonna get a good laugh out of that today. And text him later on. All right, so odd functions do what I said earlier. They just, what I was talking about was an odd. So y equals x cubed, y equals x to the fifth, y equals x to an odd number. These or any combination works here. Or symmetry about the origin. I don't know why it's something they even share it. It's not useful to know that it's symmetrical about the origin. Because no one ever thinks in like, let's go a distance d from the origin and see if we hit the line in either direction. This is what some of those smart mathematician people that like don't want to have like a purpose for math, but just want to think about the cool stuff that goes on with math, they came up with shit like this. This is not what an engineer came up with. Engineer doesn't care about that. But it is symmetry about the origin, so if you see in the homework, that's what it is. You will see odd functions and even functions again. In trigonometry or math 154, the most common one is sine x. You'll see that soon. It's an odd function. You go deep enough down the rabbit hole. Eric might have seen this, you might remember this. You can write sine as a combination of x to the odd exponent, and you can write cosine as a combination of x to the even exponent. That's much later on. That's some math fun to look forward to. You'll get to see it, Luis. You're looking forward to it. All right, so let's test for symmetry with a couple problems. Let me give you guys a couple problems and you guys can test the symmetry on. Is everyone good with that, like, picture? I don't know that I would draw on the graph if I were testing it. I would just you know, put my hand out and measure it kind of thing, rather than drawing on it. Is. Or let's see, let's do. X equals the absolute value of Y. How do we graph that? Any ideas? We've been doing Y equals stuff, and now we've got X equals stuff. It's gonna be the absolute value sideways. But that's not helpful if you don't recognize the graph. So the idea here is, if we have Y equals like f of X, do your XY table and pick values for X. When you have X equals a function of Y, I'll say G to Y, pick Y values. That'll make this easier. You'll find that this makes everything, it makes it a lot easier. So rather than doing -2, -1, 0, 1, and 2 for X, let's do it for Y. What happens if I plug those into the absolute value?
2, 1, 0, 1, 2.
2, 1, 0, 1, 2. That's right, Luis. So we graph it. Two, -2 is to the right, down 2. 1, -1 is to the right, and down 1. The good old origin's there for most of these. Guess what? The origin's not going to stay there. We're going to take the origin off the graph shortly. That's coming next. So now that we've got the graph drawn, what do we have symmetry around?
Around the x-axis.
The x-axis, right? Not the y, not the origin. Just the x-axis.
So for this, it's basically the same thing, just backwards, or just going the opposite direction.
What do you mean by that?
If you start with -2, -1, 0, 1, 2, you're gonna go, in the opposite direction, go +2, 1, 0, 1, 2.
Okay, that's what, yeah, yes, if that's what you mean by that, yeah.
Yeah.
All right, what about, oh, you guys haven't done this in a little while. So it's 2.2. What about a circle? Why don't you guys graph that and see what symmetry you have? That's a good reminder for that test coming up. Are you ready, Luis? You're not gonna graph a circle? You're gonna have a hard time passing this course. I'm gonna have a good time writing F. There goes your dreams of being a math major. You would think it would hurt my feelings to crush the dreams of a math major, but it won't. What do you think? Should we make the dean answer some of these questions? He's taken this class before. I'm not going to. Don't worry. I'm not gonna throw you in the spot like that. I think I can try to handle it. It's been a while. I'm rusty. It's rusty. Yeah. You don't get to sit in on these enough. You got to sit in on like, once a week, you'd be spot on. You'd be like the go-to person for math, biology, chemistry, physics. You'd be like the. Today I evaluated engineering. So. Engineering 2. Fun. It was, but that one was definitely over. My head. I'm looking forward to sitting in on one of Dylan's classes one of these days. Yeah, since I teach in the evenings, and he generally teaches in the mornings, I don't look good.
I just have a question.
What's up, Josue?
Because I don't remember how these like the coordinates work very well, but it should be in the center, right? The center.
Right, it's in the center, and what does the
Radius is
25
fine.
tell us?
Radius is 5.
The radius is
radius-
5.
Radius is 5 and it starts at 0.
So, and how'd you get radius is 5?
Because you square it.
You take the square
Square
root, yeah.
Yeah.
The general form of the circle is x squared plus y squared is r squared. So we're saying r squared is 25 here. And we learned to take square root. And you get r equals plus or minus 5 when we take the square root. But we are talking about a distance. It's a distance, and distances are non-negative. So we only get r equals 5. So we start at the center of the graph, which is called what? The origin. And rather than putting all the little hash marks in there, I'm just going to say, oh God, that one's not far enough left. Let's go with that one. And we go 5 up, 5 down, 5 left, and 5 right. Now remember, don't draw a diamond. There will be a circle on your midterm. Do not draw a diamond. Do not disappoint Hefe. Give it a nice little curve. Nice little happy curve. I'm gonna be the Bob Ross of drawing circles. Nice little happy curve. It's not the best circle, but it's definitely not a diamond. You should have an art contest. Who could draw the best circle? It's hard drawing a circle by hand without like a protractor or compass or whatever the hell they're called. Compass. The thing where you spin, yeah, that's a compass. That is not an easy task. So now let's look at, so this has all been centered at the origin. You guys need a 5-minute break?
Yeah.
Yeah, let's take a 5-minute break. It's been an hour. I can't. Well, I could. Let's pause it. So let's take a look. Oh, what's the symmetry here? I didn't finish the question. I just said, let's take a break. We're not even done with the questions. Like, let's just take a break randomly. This looks like a good spot. Where do we have symmetry?
And all
Across
that is-
X and Y axis.
We have symmetry about X and Y.
And
Anything
negative
else?
X, negative Y.
The origin.
Negative X, negative Y.
The origin.
Also about the origin. This one's got symmetry everywhere.
The origin would mean like if it is like a diagonal, right? That would be like the origin.
If it was what?
Like
Okay.
in how you say this, like it would be like a slope. I don't know how to explain it. It would be in the middle of X and Y. That's would be the origin, like a reflection.
That's
Yeah.
so
Or how it
it's-
works.
It's really, if I can go that way and I can go the exact same distance the opposite way.
Yeah, that's what I mean. In
I can do it
general.
over here,
Yeah, like a general
I'll
line.
call it D2. And go the exact opposite distance that way and do D2 that way. That's symmetry about the origin. So like there's no like mirror line here because it's just opposite, just go to the other side. All right, so we've been doing y equals f of x and seeing how things multiplied in front change it. Now we're gonna look to see what happens when we have like something like this going on. F of x minus h plus k. And I'm gonna show it to you in Desmos and I'm gonna let you tell me what it does. Cause I think it's just showing you it moving around and what it does. You'd be like, yep, I get it. So let me set everything back to 1 here. And I can turn off that one. Let's go back to the parabola. Now H is the one on the inside. When H goes up, what's going on with the graph? It moves to the right. Right now, H equals 3. And H has, I'm no longer at 0, 0, I'm at 3, 0. So not only did it go to the right, it went 3 to the right. And it's the opposite sign of this, what's chosen here. This says minus H, but we didn't go in the minus direction. If we go negative with it, we're now left 2. And that would be like, you would think this would say negative, but this would be x plus 2 when we plug it in. So the H causes us to move left and right. Let's put that back at 0. And now K, as K goes up, what's going on with the graph? It goes up, right? And when K goes down, it goes down.
So what's inside the parentheses moves it to on the x-axis, and then what's outside moves it up and down, right?
Yes. So the H moves along the x-axis. And it's the opposite sign of what is shown. K moves it vertically. With the same sign. And if we put them together, it moves all of the points HK over. So add H to the X value. And K to the Y value. What?
Nice.
I was wondering why something man just popped up. Something random.
Alright, so let's take a look. Let's do y equals x minus 2 squared plus 3. So I'm gonna do x and then y equals x squared. I'm gonna list our base ones. And then we're gonna look at what happens with this shift. And I'm actually gonna add 3 and 4 to my x values here. You'll see why, it'll make sense in a second. If I stick in -2, I've got -2 minus 2 squared. -2 minus 2 is -4. We square -4, we get 16. And then we add 3, we get 19. We're gonna follow this pattern on each of them. -1 minus 2 is -3, we square that, we get 9. We add 3, we get 12. I plug in 0. I have -2 squared is 4. Plus 3 is 7. I put in 1. 1 minus 2 squared, 1 minus 2 is -1, we square it's +1. We add 3 to it, we get 4. We stick in 2, 2 minus 2 is 0, and we just get that 3 back. Three minus 2 squared is 1 squared plus 3 will give us 4. And now we're starting to see that symmetry. We had the 4, 1, 0, 1, 4, and I've got 7, 4, 3, 4. If we look at 4, we get the 7 here. 4 minus 2 squared, 4 minus 2 is 2, squared is 4, plus 3 is 7. So if we realign it, like this symmetrical part right here is now here. So it's kind of like it's shifted down to, or shifted right to, because these are the x values that moved. And rather than having 4, 1, 0 originally, we have 7, 4, 3. If we just graph these 5 right here, let's do those 5 right there. The bottom 5. No one wants to graph 19 and 12, that's just a pain in the butt. But we can graph 7. We have 0, this is 0, 7. 1, 4. 2, 3. 3, 4. And 4, 7, pulling the X value from the left side. So that puts us there. There. There and there. Now remember with x squared, I was saying we do right 1, up 1, right 2, up 4. From here, this still applies. This is 2, 3. That's my HK. You guys see that? H is the opposite sign of what's in here. K is the one on the outside. And I can still do the up 1 over 1 from here. Up 1 over 1. I'm sorry, right 1, up 1, right 2, up 4. Same thing with going to the left. So rather than doing this pain in the ass table, I think we can all agree that was pain in the ass. The better way of graphing this, you gotta do it the hard way first, and then you're like, then you appreciate the other way. We identify what H is and K is. If it helps, write a X minus H squared plus K. That way you can match up what's going on. K equals 3. H equals 2. Because the signs match. So, the better way of doing it is rather than starting at the origin, go over to 3 and do your right 1, up 1 there. Left 1, up 1 there. And draw your parabola from there. Let me give you guys one to try. Let's see. Let's do. Y equals the absolute value of X plus 1. Plus 2. Try graphing that. And preferably without making an XY table. Assuming you remember what the absolute value of X looks like. Too bad you didn't come to my Calc 1 class or my CSCI 2 class. I've renamed one of the students Voldemorta. She likes it.
What time was that?
It's 8 a.m.
Just swamped a bunch of people.
I know you are. I figured the afternoon one was probably what you're gonna go for because a lot of teachers do theirs in the morning only. With me, you got some range. Where's Drew? I wonder if this is the drop date blues. I wonder if I lost a bunch of people that showed up in person.
How many people are still in the class?
Oh, 6 people are in the room right now when there's normally 10. And there's only 3 of you online when there's normally 5 or 6.
There's only 6. There's 6 people in the class?
Not counting me. And
Okay.
my
That's
colleague.
5. That's 3. And I mean,
What?
that's how many how many students are?
I told you 6.
6 students? Oh, okay. But you said not counting me. I
Not
was-
counting me. I'm not one of the 6.
Oh, yeah, that's all people.
You're messing with me, I swear. Jimmy said he's gonna keep himself muted so that I can only pick on you, Luis. What is that? What is that about? Do you guys know each other outside of class? You have this little fun rivalry. I love it. Jimmy had to hide though. He had to hide. Couldn't even show his face no more. You let barely 18? You let a barely 18-year-old chase you out of class, Jimmy. Shame.
Never that.
All right, so how do we do?
The
What is HK here? Let's start with that.
-1.
Negative
-1. -1 and 2. 2.
Does everyone, I hear ya. Just soldiers, hold your roll there, Josue. Did everyone see that? We use the opposite sign of what's there and the same sign as what's here. So. The XY normally, it just makes everything positive. If it helps, while you're first, until you've mastered the basic graphs, draw the basic one, y equals absolute value of x. I'm gonna do dotted lines because that way I can still see it, but it's not my official graph. And what I'm gonna do is I'm gonna drag those points. This one was here, I'm gonna drag it -1, 2, and put it up here. This one was 1, 1. I'm gonna drag it -1, 2, and put it there. We should get the V going on there. Why am I doing a dotted line? I can just draw it. We could go on and on for hours on this 2.7, but we gotta get to 2.8. I gotta show you some stuff at 2.8. So 2.8, function operations and composition. Let you finish, guys, writing this one down. Yeah,
I just have a question. If there's a negative sign, like outside of the absolute value, it should reflect it to the x-axis, right?
it kind of reflects it from where its position is.
But if it is inside, but it is inside,
we-
for example, the
So if
x
we
is
have like
negative.
this,
Yeah,
that's what you're asking, right?
yeah.
Let's just see what happens. Let's see where this point ends up.
Yeah.
Where does 0 end up now? If I plug in x equals 0, I got 0 plus 1 is 1, absolute value of 1 is 1. But then I make it negative, so it's -1 plus 2 is +1. It's right there. The negative is reflecting it here. So a better way of saying the reflections are about not necessarily the y and x-axis, but the negative out front reflects it across.
Have a great afternoon.
You too. Reflects across the y equals k axis. Y equals k line. When k equals 0, this is y equals 0, and that ends up being the x-axis.
Because there's some cases where it reflects across the x-axis. Oh, wait. When you said it reflected?
Where are you going?
Okay.
You're done? We're getting to the good stuff.
Look at that.
It's like, I'm done. I sat through your dean here. Be happy I was here this long.
Okay. Later.
See you on, what day is it? See you on Monday. All right, so let's take a look at this 2.8. 2.8 is on function operations. And composition. So this is just lazy mathematicians came up with this shit. You just have to remember what it means. We have two functions, f of x and g of x. When we add them together, they decided writing this was too much work, and they write it like this. Now, if you match up what they did, I've got f and g right here, and the plus is right here. I've got two sets of parentheses, but I've only got one x. This one not listed. Writing in this notation saved them one letter. That's all it saved them. It saved them an x. And they felt this was necessary. I think writing the x, leaving it as this is a better way. This is not confusing. This is confusing. If you have to stop and explain something that you're only saving something that takes you a fraction of a second to do and little to no space on the page, are we really saving them any time? We've just actually made it worse. That's my opinion. I didn't make the rules though. I have to be stuck with what a bunch of amateurs like Newton and all those people came up with. We have f of x minus g of x. Guess what happens here?
Negative. So
Negative instead of a positive. When they have f of x times g of x, they don't even put the goddamn dot. They just say fg x. They're like, oh, we can save two characters, an x and a dot. And f of x over g of x is FG over X. The only real difference is with what's going on is the domains. The domains of these combinations. Are the overlap. Of the domains of the original. For a lot of things, it's all real numbers, so, and both of them are all real numbers, so they together are all real numbers. The only difference is on the division. For the division. G of X equals 0, whatever X value that is not in the domain anymore. X value that yields the 0 is not in the domain anymore. That's for the G of X because it's in the denominator. Oh, Francisco missed the tip.
Wait. Good then. Fine, I took a picture.
You guys ready? Look at some examples. F of X equals 3x minus 4. G of X equals 2x squared minus 1. So first we will find F plus G of 0. There's two approaches to this. So approach number 1. Let's just do F of 0 plus G of 0. My F of 0 is 3 times 0 minus 4. Then I've got a plus. I've got G of 0 is 2 times 0 squared minus 1. That looks like division. Maybe I should do this. That doesn't look like division anymore. We have -4 minus 1 is -5. F plus G of 0 is -5. Does that make sense? I plugged in X equals 0 on each of these and just replaced X over here. Since we're adding them together, I showed them being added together. Okay, so like if you only need one number, only need to do it for one number, that's the easiest way to do it. It takes the least time. Option B is to do F plus G of X first. by adding those together. 3x minus 4 plus 2x squared minus 1. F plus g of x is 2x squared plus 3x minus 5. Now evaluate at 0. This way works great if you need to do more. Like if we needed f plus g of 1. I've already got it set up, I can just plug it in and. Doesn't do a whole lot of gain on this problem, but some problems it really speeds it up to do this work ahead.
Yeah, never mind.
Is that the 3x negative 4 or 3x? What is that sign? The one you try to correct or you raise it?
It's the same as the originals.
Oh, okay.
So that's my F and that's my G. It's a minus sign. F minus G can be tricky if you do it ahead of time. You should do it in parentheses. Oh, yeah. Damn, Francisco really missed the show. Poor guy. He's missing the good stuff. If we put them in order. So all of these, if we did stuff for F times G and F divided by G, they're all gonna have the same domain, except, so the domain for all of these is all real numbers. Because both of these are all real numbers. Except F divided by G. We're gonna have 2x squared minus 1 on the bottom. And we don't want 2x squared minus 1 to equal 0. So if you solve for that. You get that. X can't equal plus or minus square root of 2 over 2. So the domain for the division would be negative infinity to negative square root of 2 over 2. Oh, this is a fun one to write. So f over g x. The domain is negative infinity to negative root 2 over 2 in union with negative root 2 over 2 to root 2 over 2 in union with root 2 over 2 to infinity. This is how you show, this shows not x equals negative square root of 2 over 2. And this combination shows not x equals positive square root of 2 over 2. I guarantee you there will be one of the next problem on the exam. It's called the difference quotient. Difference means subtraction, and quotient means division. The different quotient is f of x plus h minus f of x over h. So let's say f of x equals 3x squared minus 2x plus 4. Find the difference quotient. This will be on the exam. It is fundamental to calculus. It's the very idea of how derivatives work. We base it off of this formula right here. So it's really important you know what it is for anyone going on in the sequence. So let me let you write that down and then we'll do them together. So we already know what the f of x is. We already have it. What is f of x plus h? For this, everywhere we see x, we would replace it with x plus h. And you should do it in parentheses. X plus h squared is x plus h times x plus h. So if I actually multiply that out, I have x squared plus 2hx plus h squared. And I'm gonna leave the rest the same for now. Just dealt with the square on that line. Then we'll distribute. So that's f of x plus h. I'm gonna rewrite f of x below it. And I'm gonna line up the stuff that we have. I have a 3x squared, it goes underneath that 3x squared. Negative 2x is right there. And the plus 4 is right there. So that when I subtract, those go away. What I have left is 6hx plus 3h squared minus 2h. Everything has an h in it. So if I do f of x plus h minus f of x divided by h, I can factor out an h out of everything that was there. I'll have an h on bottom. So I just pulled out the h from each of these. Factor it out. That gives me this h right here. Now the h's cancel, and I'm left with 6x plus 3h minus 2. And there will be examples to try on the homework. You get some practicing. Last topic, composition of functions. We did a lot of operations with adding and subtracting and stuff like that. But what if we, and like here, I have x plus h inside of f. So I can put other things inside of f besides numbers. What if I have f of x and g of x, and g of x equals x plus h? Then f of g of x, like this, is the same thing as f of x plus h. And we just saw us use that. So this is called composition of functions. And they give it a notation like this. They say f of g of x, we were going to write it as f, it looks like fog x. It really does. It's terrible. Looks like fog x. It's usually in parentheses. FOG. It doesn't look like a normal O usually, but when we handwrite it, it sure as hell does.
I think on the, it's on some calculator time, it's like smaller.
I have no idea.
I think so, yeah.
And I guess if it stores functions, it would do it. Ooh, that was right. Don't come up here. All right, let me give you an example. I'm gonna say. F of x equals 2 over x. G of X equals square root of X plus 4. If I do fog X, F of G of X, this is putting G of X inside of F wherever X shows up. This would be 2, and we're going to replace X with the square root of X plus 4. This is where the domain thing's a little weird. So we can only plug in things that, first off, they need to work for G of X. The domain of G of X, normally we want X plus 4, we want the inside of a radical, needs to be positive. It needs to be non-zero. Non-zero, if it's negative, we get the i's in there, the complex numbers. So we want X plus 4 to be greater than or equal to 0, which means X is greater than or equal to negative 4. That's the domain of G of X. And so f of X is going to be restricted to that. So f of G of X is restricted to the same domain except where it causes problems. If I plug in negative 4, I get square root of 0 on bottom. So X equals negative 4 doesn't work. So I have to restrict the domain a little bit more. X is greater than or equal to negative 4 becomes X is greater than negative 4. That's the domain of f of G of X. Or fog X. It doesn't always have to go in that order. They will do, I'll use the same stuff and we'll do Goff. So what we have is X plus 4, but we're putting the 2 over X in place of the X. This is Goff X. Now we want the inside needs to be greater than or equal to 0. So we could get a common denominator. And this has, like, we did the sign chart of stuff like this before. Let's see. We set the bottom equal to 0, that's a bad spot, and we set the top equal to 0. You get x equals -1/2 there. Those are bad spots. We also have the restriction that was with g of x. Or f of x. F of x is on the inside. X cannot equal 0. Oh, we already have that. It shows up still. And so we have -infinity to -1/2. We need that greater than, so we need to actually do a sign chart here. If you do a sign chart, this ends up being positive, and that ends up being negative. We're out of time, otherwise I would walk you through it. The -1/2 gets the bracket. The 0 doesn't. That's the domain. We did that in, like, I don't know, 2.4 or something like that, rational inequalities. That covers everything that's gonna be on the test. There's that midterm review up in the announcements. I recommend trying to do it without looking at the solution of the video, then checking your work on it. I am having my wisdom teeth pulled on Friday, but I'll presumably be somewhat at the keyboard on and off over the weekend. Unless I'm narcotic dubbed. You can always send questions on Discord or email me and ask questions.
What did you say? What did you say about a video?
It's in the announcements.
Oh, but that video is about what?
I'm gonna show you.
Oh, okay.
All right, I have it right here. Hey, there's an announcement. It says midterm review. This top one is a practice thing. The midterm, this one right here, the second one is the paper written, the paper I wrote on for the video. So this will show the solutions to that by paper, and you can watch the video on how to solve it afterwards as well, but try to do the practice midterm without it before then.
Oh, do you mean the one that is in the lab, my lab?
No,
Or which one?
it's on the fucking screen, Josue.
No, but I mean, this is like a guide for the my lab. I don't know. I'm
No,
asking.
it's a guide for this fucking exam right here.
Oh,
You're fucking with me.
I'm just asking. I don't know. Maybe.
But I'm telling you, the exam's right there.
Okay.
This is the exam.
And as long as we
practice
do
exam.
well on this one, we're gonna be fine in the midterm.
The midterm's a paper test. So like the My Math Lab is all just practice stuff.
Okay.
Your
but with this
midterm for the
practice,
class is on paper.
if we do well in the practice, it will be probable we do well in the midterm.
That's usually a good sign.
Okay.
It also
then.
tells you what you need to study more.
Oh, okay then.
Okay?
How many questions will be the midterm?
10.
10?
Yeah.
Okay.
I think he's fucking with me here.
No, I'm just asking.
I answered all this at the beginning. Oh, you weren't late, weren't you?
I was late?
I went over this the first 5 minutes of class.
Oh yeah, I was starving and I went for food and I came like 3-5 minutes late.
All right, have a good day.
Have a good day.